Part A of this problem asks us to find the increase in sound intensity level when there are 4 babies crying rather than just 1 baby crying. I'll draw 4 dots here to represent the 4 babies with a person's ear. The sound intensity level, beta, is 10 log sound intensity I over reference intensity I naught. The difference in intensity level, delta beta, in this case between 4 babies crying and 1 baby crying, equals 10 log I4 over I1. The intensity of 4 babies crying is 4 times the intensity of 1 baby crying. So we see that delta beta is 10 log 4, which works out to 6 dB. In part B, we're asked to find how many more babies are required to get an additional 6 dB increase in sound intensity level. So I'll draw these red dots to indicate the additional babies crying that we need. The change in intensity level, delta beta, is now the intensity level for n babies minus the intensity level for 4 babies. That equals 10 log n times the intensity of 1 baby crying divided by 4 times the intensity of 1 baby crying. And we know that that equals the same value we calculated in part A, 6 dB. Now we need to solve for the number n. If we divide by 10 and then make each side of the equation the exponent of 10 to get rid of the log, we find that n over 4 equals 10 to the 0.6, and that equals 4. So we see that n equals a total of 16 babies altogether. We started out with 4 crying babies. We need 16 crying babies altogether. That means we need to add 12 more crying babies to increase the sound intensity level by 6 dB.